Welcome to part 4 of my Dash shell scripting tutorial. In this episode I will be looking at iteration. There is 3 looping constructs I will be discussing in this video. First off, there's the while loop, then there's the until loop, which is actually just a while loop with an inverted condition, and then lastly there's the for loop. After I've discussed the different types of loops and how you can control them, I will look at some of the keywords which are used to control loop iterations. The first is the break keyword, which we can use to exit a loop. The second is the continue keyword, which we can use to skip the rest of this iteration. Then we will revisit the return keyword, which we can use to return from the current function we're in or the entire script if we aren't in a function. And lastly, I will be looking at the shift keyword, which is a bit of a special case. It's not specifically tied to loops, but it does make the most sense to use it in the context of a loop. Let's start with a while loop. The while loop, like an if, has a condition which it tests. But the while loop keeps repeating until the condition is no longer true. So here we're defining a variable named I, which is going to be what we are iterating on. And our while loop has a test that verifies that I is less than or equal to 10. And then it prints I. Now normally you'd have to change the variable, but here I want to actually show you that it's going to hang. Here you can see that we get an endless number of ones. So what we're going to do is every iteration of the loop, we're going to add 1 to I. And now you can see that we have a simple iteration. So we have a while loop, and in the body of the loop, which starts with do and ends with done, I believe I said in an earlier episode that you usually reverse the keyword, but that's not true for loops. We print the number that we currently have, and then we raise the number in the variable by 1. And then before the execution of the next iteration of the loop, we test the condition to see that I is less than or equal than 10. And if I is no longer less than or equal than 10, then we proceed normally. So here you can see that it just exits the loop and continues at a normal point in the control flow. Now there's another keyword which we can use for loops, which is the until. And as you can see, the loop isn't run now. The until is exactly the same as the while loop, but the condition is reversed. So if we reverse the condition, we get the same result. Or alternatively, we can say run this loop until I is larger than 10. And we get the same result as well. For loops are a different type of loop, and for loops iterate over a list of values. In its simplest form, we just enter the literal values we want to iterate over. Some programming languages have a construct named a for each loop. The for loop is very similar to that. You can also call an external command. The sequence command, we can normally use it on the command line to iterate over numbers until the specified number. Here we're doing a little bit of a silly thing. We're calling the command, storing, iterating over it and printing it, even though if we just say sequence 10, then it already does the same thing. We can also iterate over the parameters that the script gets. In fact, even if we don't specify in and then the name of what we're specifying, it still works because by default the parameter refers to the parameters to the script if we haven't set one specifically. We also have the option of using wildcards to refer to files. So here you can see by specifying star.txt, we're actually iterating over all the files with the .text extension. Now the for command expects white space separated input. So let me make that a little bit more clear what I mean with that. I am going to modify the a.txt file which we created earlier. And as you can see, I've created two lines with text on them which have spaces in them. Now if I run the script and the cat command contains the contents of the file, then you can see that every space separated value in the file is a separate iteration of the loop. Sometimes that's what we want, sometimes it's not. Now there's a read command which is able to read from file descriptors, and we can use this in a loop to achieve line separation of the data. But we need to use a while loop for that. And as you can see, if we feed the text file to the loop using the smaller than sign, a redirect, then with the read parameter, with the read command, we can store the line into a parameter and print it. The read command also allows us to specify space separated values. So now we're going to iterate over the file, and every line in the file is going to be an iteration, but we do split the data so that we can use it in whatever way we want. So as you can see, the first word in the file is placed into a separate variable, and the second part is placed into another variable. As I mentioned earlier, there are several ways to change the flow of execution in a loop. So let me create a simple loop that just prints 7 numbers. There we go. Now the first way to change the flow of execution in a loop is by using the break keyword. So what I'm going to do here is I'm going to check a condition, and if the condition is true, then I'm going to break out of the loop. And that condition will be that the number which we're looking at is even. So the rest after division of the number that we're currently iterating over, divided by 2, is equal to 0. If it's equal to 0, then break out of the loop. And as you can see, the loop iterates for 1, then the loop iterates for 2, then it gets into the test, which passes, and it breaks out of the loop. So with a little bit more detail. Does this work? No, it doesn't. That's it. So the first iteration, 1 is not equal to 0, so it just prints 1. Then after division, the remainder is 0, which is equal to 0, so we execute the break and it stops. Now the second way we can change the control flow through the loop is with the continue statement. Now, similarly to the break statement, the iteration stops executing when we use the continue keyword. But unlike the break keyword, continue doesn't jump out of the loop entirely, but it just jumps to the next iteration. So now you can see that for every even number, the continue is triggered, and the echo statement, which is in the rest of the loop body, is no longer executed. Now it would be possible, instead of the break example, to use the return statement. As you can see, we get somewhat the same result as with the break statement, except that the after statement is no longer executed, because the return statement doesn't operate at the level of the loop, but it operates at either the level of the function we're in or the script where we're in. Now we're currently not in a function, so this just exits the script entirely. And you can see that the return code of the script was the return value which we gave. Now there are also ways, I believe if you give the break statement a parameter with a number, then you will jump out of that many loops. And you can probably do something similar for continue, but I would prefer to write code in scripts in such a way that you don't have to use those cryptic means, so I won't be going into those into detail. Now the last, and I said it was a control flow keyword, but I don't think it actually is. I think it's more like a built-in command. But the last command I want to discuss is the shift keyword. So what you can see here is that I am printing the first parameter to the script, calling shift, and printing the first parameter again. Now the shift keyword, what it does is it basically removes the first parameter and shifts every other parameter to the left. You can even shift more than one parameter by giving it a number. And here you can see that the shift 2 shifts out both A and B, so C becomes the first parameter. Now the shift keyword is often used in loops for processing input. So in this loop we will be testing that there are still some parameters left. If there are, print the first parameter and shift it out. Now if you print the parameters after the loop, because we've shifted them out, you see that we're printing an empty line because the parameters are no longer there. So in some cases you would prefer to use the for loop, which we saw earlier. So in this example, we're printing the parameters to the script one by one, but we're not shifting them out of memory, I guess. So when we're printing all of the parameters to the script after the loop, then they're still there, as you can see. I will be creating one example script in this lesson. I will be creating a simple example script that automatically finds and mounts file systems. Now normally when you start Windows, it automatically mounts all of the hard drives and all of the USB sticks that it finds. However, Linux is a little bit of a different approach. Linux normally only mounts file systems which are registered in the etc fstab file. And here you can see that the root file system is being mounted, which is indicated by the slash, that the swap file is being mounted, and also the /boot/EFI, which I believe is some sort of integration with the motherboard firmware. Now as you can see here, there is also a USB stick which only has a data folder on it, but it wasn't automatically mounted. Now most distributions of Ubuntu automatically mount the USB stick when you insert it, and it's actually the file manager that does that. Under ICE there is not normally a file manager running in the background, so it doesn't automatically mount it unless you have a file manager open. But we will be creating a script that we could call on startup to automatically mount it. But first, before the first command, I will be looking at some commands first, which I will be using in the scripts. The lsblk command is a command that shows us the different kind of devices, block devices, which are available. It's kind of like an ls command for block devices. So you can see that it creates a little tree structure with the devices, and I have an SDA-A and an SDA-B, where SDA-B is the USB stick and SDA is the hard drive containing the two mount points which we already saw. Now in scripting we don't really need the header, so we add the N flag to drop this header here, and we switch to list mode so we don't get the tree structure, because we'd have to parse that if we used it in a script. Now normally if you were to mount a file system, you'd first need to create a mount point. Once you've created a directory, then you can choose to use the mount command. Like so. As you can see, you need elevated privileges for this. Now it's mounted. And you can also see in the file browser that there's now an icon indicated that it's mounted. If we want to unmount a device, we use the umount command, and you don't need to specify the location, only the device. And you can see that we also need elevated privileges here. Oh. Wait, did it show the contents? Yes, it does. Okay, now it's unmounted and the icon disappeared. But in our script, I want to create the script in such a way that we don't need elevated privileges, and Ubuntu also has the udisctl command. As you can see in the file browser, I can mount and unmount without elevated privileges, and the way to do that from the command line is with the udisctl command. And you can see that it gets mounted. Now we have to say the full unmount word to unmount it. So I will be using these commands to create a simple script to integrate the knowledge which we saw in this lesson. Now I forgot some of the commands I just realized, but I'll just discuss them as we're writing the script. So let's write a simple script, and let's start by listing the devices we have available. I'm just going to leave this in here, but it's not actually a great way to use it in a script. So we saw the no header flag and the list mode before, which gives us a simplified version, but all we need is the name of the device. So this, the O flag specifies which columns we want, and we only want the name column. So now that we have that, we have something we can iterate over. And there we go. I'm going to leave a blank line below the specification of all of the drives. So now we're iterating the available devices, and we're just printing them. Next we need to know which devices are already mounted. And this is one of those commands which I hadn't really discussed yet. We can access them from the proc mounts file. And you can see that it gives a bunch of output. And I am currently only interested in the ones that start with that. Grep. Oh, that's supposed to be a pipe. So there we go. We can see that SDA1 and SDA2 have been mounted and nothing else. Okay, so we can ignore any devices which have already been mounted. So I'm going to test to see if the current device is registered in proc mounts. And if it is, then we will print a message and use the continue statement that we've seen in this lesson to stop the rest of the iteration of this loop. Oh. Better. So you can see that the devices which we earlier said that they were already mounted are already mounted. If I place a statement after this, then you will see that the mounting statement only printed for the rest of the devices. But we still want to check the actual type of the device. So now that we know that the device we're currently dealing with has not been mounted, we need to figure out what kind of file system this device has. I don't believe I discussed this already, but the udisctl command also has an info. I'm not sure if I can call it a flag or argument, I guess. which you can use to get more information on a particular device. And as you can see here, the verbatim USB stick has the VFOT file system type, which is called ID type, I guess. I don't see a file system flag, or how do you call it, entry. Yeah, so I guess it should be ID type. Now I want to create a simple function which I can use to extract the value of one of the entries in the output. And I'm storing the full output in a temporary variable so that we can extract multiple values without having to go back to the script, to the udisctl command. So let's create a simple function to extract a value, which will be taking two arguments. And the first argument is going to be the full output of the command, and the second output will be the entry which we are looking for. And we will be using grep to find the appropriate line first. So print the full output, then send it to grep, find the expression we're looking for, and then we will use a regular expression to extract the value of the entry. And we are looking for something that starts with any number of characters which are not a colon, then any number of spaces, and anything that follows the spaces will be extracted. And we were looking for the ID type and the ID label. Whoops, we still need a slash here. So the expression command, if it doesn't find a match, it returns an error code. It's not finding anything. Now, expression still isn't correct. Better. So we can see that for SDB1, it finds that its label is verbatim and that the type is VFAT. So let's store that in some variables. And now we are going to limit the file system types which we are going to mount. Okay. And we could use an if just for VFAT, but since this is a chapter on loops, I will say mount anything that has the type vfat or ext3. So we will be looping over the various file system types which we support, and if the file system of the current device matches any of the file systems we support, then we will mount it. So here we need to check that the type of the current device is equal to the accepted type which we are currently iterating. And if it is, then we will mount the block device. Mm-hmm. 936. Oh, what just happened? But it doesn't have 36 lines. Maybe there's an empty string somewhere for one of the drives. Okay, let's fix the error. So what probably happened there was that we had that the SDB device doesn't have a type, since it's the root, and therefore if you put double quotes around a variable if you put double quotes around a variable, then if the variable is empty, then it still counts as a string. Well, without those quotes, then it just counts as if that there is nothing there. So that's why we got that odd error above, where there was an unexpected error because there was nothing to the left hand of the test. Okay. So now we've created a simple script that will automatically mount anything that is vfat or ext3. So if I run the script, you can see that it's being mounted. So you can simply run this script and you don't need any elevated privileges anytime you want. So I could even run it like this. And in the ICE window manager, you could say you can add a startup script, and if you would add the script here, Then it will automatically run it on startup, and when your computer starts up, then it will automatically mount all of the drives.